Hey guys, welcome back to another video. In this video, we'll be teaching you the basic integration rules. And these rules will be used to integrate constants and variables. And without further ado, let's get right into the video. So our first integration rule here is that the integral of 0 with respect to x is equal to c. This only applies to 0, by the way, not any other constant. For constants that are not 0, so we'll call them k. With respect to x, this is equal to kx plus c. An example of this would be 7 with respect to x is equal to 7x plus c, like so. And for our next problem here, we have kf of x. This is equal to k times the integral of f of x with respect to x. Oh yeah, don't forget the respect to x thing. With respect to x, this is pretty important. As you can see, it's easily forgotten if you go fast, like what I did right there. So this would be equal to k times the integral of f of x with respect to x and plus c. And you don't really use this one a lot, but when you do, I'll show you what you would do later in the video at example problems. So another one would be f of x plus or minus g of x with respect to x is equal to the integral of f of x with respect to x plus or minus, depending on the sign you used earlier, the integral of g of x with respect to x plus c. And for another one, we have the integral of x to the nth, so the exponent one, with respect to x is equal to x n plus 1 over n plus 1. And then we have the integral of cosine of x is with respect to x is equal to sine of x. We have the integral of sine of x with respect to x is equal to negative cosine of x plus c. Don't forget your plus c's. I just forgot them again. And this will go as a reminder to not forget your plus c's. And I'll move this a little farther away so it's easier to distinguish. So yeah, don't forget your plus c's. And then we have the integral of secant squared of x with respect to x is equal to tangent of x plus c. And then we have the integral of secant of x times tangent of x, all with respect to x, is equal to secant of x plus c. And then we have the integral of cosecant squared of x with respect to x is equal to negative cotangent x plus c. And finally, but not least, we have the integral of cosecant of x times cotangent of x with respect to x is equal to negative cosecant of x plus c. So make sure that you memorize these right here. I'm going to highlight them in green for you, like so. Make sure you memorize these, take a screenshot of them, just make sure you have them at your use. And then we'll move on to the example problems here. So for our first example problem, let's say that we are asked to find the integral of x to the 2/3 with respect to x. And actually, I'm going to rewrite that. X to the 2/3 with respect to x. Well, this would be the same thing as x to the 2/3 plus 1, 2/3 plus 1. And if you're wondering where I got this from, it's from this property right here. X to the nth with respect to x is equal to x to the power of n plus 1 over n plus 1 plus c. And something that is useful here is that the exponent of x and the denominator will always be the same. And this can be pretty useful because sometimes it's a hassle to calculate both at the same time when you can just realize that they're both the same. In this case, it would be x plus, or x to the power of 5/3. And I'm going to rewrite that because it's a bit sloppy. 5/3 over 5/3 plus c, which we can rewrite as 3x to the 5/3 over 5 plus c. Now, for another example problem, let's say that we are asked to find the integral of 3x squared plus 1 with respect to x. In order to solve this here, we would simply just find the integral of 3x squared and the integral of 1. So the integral of 3x squared can be rewritten as the integral of 3 times the integral of x squared with respect to x, and then it'd be plus the integral of 1 with respect to x, and this is equal to 3x cubed over 3 plus x plus c, and this right here can be rewritten as x cubed plus x plus c, like so. Now let's move on to some trig integrals here. If we are asked to find the integral of 2 cosine of x with respect to x, this would just be equal to 2 to the power, or 2 times the integral of cosine of x with respect to x, and this is equal to 2 times sine of x plus c. And for our final example problem, but not least, this one might be used in your test or quiz because it involves other things besides integrals, but I'll call this one the quiz/test problem. This will be sine of t over 1 minus sine squared of t with respect to t. So for this one right here, the first thing to note is that it is t and not x. So make sure that you write in terms of t, otherwise you're going to mess up the problem. So the first thing to note here is that 1 minus sine squared of t, according to the trigonometric identities, and if you haven't memorized those yet, I suggest you memorize them because they're used a lot in calculus. So this is equal to cosine squared t. So we can rewrite this as sine of t over cosine squared of t with respect to t. And then what we can do from here is rewrite this as sine of t over cosine of t times 1 over cosine of t, all with respect to t. And then we can just rewrite it again as tangent of t times secant of t with respect to t. And if we look back at our integration rules, we see that secant of x times tangent of x, the integral of that is just secant x plus c. And this is tangent of t times secant of t, which is the same thing thanks to commutative property. And since this would just be secant of t plus c. So if you enjoyed this video, please consider subscribing If you learned something from it, please like the video, comment what subject or math you need help with in the comments, and as always, have a wonderful day.